Hello, my name is Alicia Glover, and I'm the Manager of Strategic Partnerships with the South Island Prosperity Partnership and the Project Coordinator for Coast. I am opening today's event from the territories of the Lekwungen peoples, today known as the Esquimalt and Songhees Nations. Coast is committed to working with First Nations, to respecting their longstanding relationships to the lands and waters, as well as their leadership as innovators and stewards of these territories. I invite everyone joining us today to take a moment to reflect on the territory from which you are joining this conversation. Welcome to our September Coast Talk with BC Ferries. For those new to Coast Talks, Coast stands for the Center for Ocean Applied Sustainable Technologies, a new ocean innovation hub based in Victoria, BC. Coast's mission is to drive inclusive prosperity in British Columbia's sustainable blue economy through entrepreneurship, innovation, and expansive partnerships. The Coast Talk series was launched to showcase some of the organizations, innovators, and companies working hard to build a sustainable sustainable ocean future. Today's talk is one of 6. You can sign up for upcoming talks on our website, canadacoast.ca, and view past talks on YouTube. Today, I'm delighted to introduce you to Captain Jamie Marshall, the moderator of today's conversation. Captain Jamie Marshall is Vice President of Shipbuilding and Innovation at BC Ferries. He is responsible for investing in and acquiring a new innovative fleet of vessels for BC Ferries. In addition, he is accountable for identifying and developing strategic business opportunities to grow and diversify the company's revenue. Previously, Captain Marshall served as Vice President in various capacities, Marine Superintendent, and as a captain in the fleet. Prior to joining BC Ferries, he served as an officer with the Royal Canadian Navy. Captain Marshall has a Master's Certificate of Competency, a Bachelor of Science from the University of British Columbia, and is certified by the Institute of Corporate Directors. He was awarded a fellowship of the Nautical Institute. In addition, he has or is currently serving as director on the following boards: Pacific Pilotage Authority, Canadian Ferry Association, the Association of BC Marine Industries, and Coast. Over to you, Captain Marshall.
Well, thank you very much, Alicia, and welcome everybody to today. We're really excited here at BC Ferries about this topic. This is it's near and dear to our hearts, the electrification of our new Island Class vessels. Just to put it into context a little bit, we started this program several years ago where we built the first 2 vessels, which are currently in operation. They've been in operation for about a year, and they are operating up in Port McNeill and also on Texada to Powell River. The next vessels, the first 2 have arrived, vessels 3 and 4, and vessel 5 is just off the west coast of the United States right now, on her way up to Victoria. We're expecting her here early October. And vessel 6 just finished her sea trials, and we took provisional delivery of her yesterday, and we're looking forward to welcoming her here after her 60-day, 10,700 nautical mile voyage, of which is interesting, a third of that voyage will be on battery only. These vessels, as you'll hear in the presentations where we talk about the full electrification of them, the terminal infrastructure upgrades, and the environmental benefits of these vessels operating on the West Coast. It's an exciting time. We'll dive right into the presenters. Our first presenter is Ed Hooper, and Ed is the Executive Director of Shipbuilding, and he joined BC Ferries in 2019. He's also responsible for directing the company's shipbuilding programs. Over the past 2 years, he has led efforts leading directly to the delivery of 5 BC Ferry vessels, and the 4 vessels that I talked about earlier are going into service in early spring of 2022. Previously, Ed served with the Royal Canadian Navy, holding various positions, including his final assignment as commanding officer of the Navy's West Coast Fleet Maintenance Facility. A former professional engineer and project management professional, he holds a master's degree in mechanical engineering from the University of Calgary and in military and political sciences from the Royal Academy of Belgium. Welcome, Ed.
Thanks, Jamie. I hope everyone can see the presentation now and can hear me all right, but I'm going to carry on with a general overview of what the Island Class Electrification Program is all about. So we'll just carry on with that. As Jamie has already mentioned, the Island Class, it's a new class of vessels that's entering the BC Ferries fleet. These vessels were designed and built at Damen Shipyard's Glatz in Romania. The first 2 vessels, as Jamie mentioned, have already entered service and have got about a year's worth of service already delivered. And the 4 more are being built and delivered in various stages of delivery at the moment. So there's the overview for you. The vessels were designed with a vision that at some point we would be able to operate them in a fully battery electric mode. The ships right now have got diesel engines on board. We use the diesel engines to recharge the batteries, and we use the batteries to make sure that we can operate the diesels at the most economic, fuel efficient capability. So already they're very clean, very fuel efficient, very quiet vessels. But what we want to do is go one step further on. This slide here is really just an overview of what it is we intend to achieve with electrification. So the federal government, the provincial government, international standards, and BC Ferries ourselves, we all have targets, we all have objectives that we want to achieve to reduce our reliance on carbon-intensive fuel sources and to reduce ultimately the amount of greenhouse gases and other emissions that are going into the environment. So if you were to go online, you can Google, for example, the Clean Futures Plan for BC Ferries or the Strategic Energy Management Plan. You can find these documents and they'll talk in more detail about what it is that we're trying to achieve. But for the Island Class, we recognize that there's an opportunity here with vessels that were designed with a future potential for electrification to go very quickly into a mode of operation where they should be able to plug in ashore, recharge from clean BC hydro electricity, and then reduce our reliance on fossil fuels and therefore reduce the amount of pollutants that are going into the atmosphere. So the program itself, we have 6 ships. We have ships that are in service. We have 4 more ships in various stages of delivery. And really, we should have all of these vessels going into service by 2022, as Jamie has indicated already. They are currently configured to operate as diesel electric vessels, but our objective is to convert them for battery electric. And what that means is we would install more of the same batteries that we already have. We would install additional cables that would allow us to recharge those batteries from a shore-based connection. And we would install some additional transformers and switchboards to make sure that it's all done safely on board. At the same time as we're doing that, we have to look at where the electricity is coming from. So the other part of the scope, the big part of the scope of this program, is to upgrade the terminals. So we need to get BC Hydro to work with us and bring that kind of high power, high voltage electricity that we need right to the terminal. And then we need to do some transformation of that power and bring it right to the berth, install some kind of a high power plug, really a connection that we can transfer the power from ashore to the vessel. And that would allow us then to recharge between each of our crossings and run the vessels exclusively on their batteries. The rough timeline that we have in mind is 2022 to 2025, when we should be able to do all of this work, upgrading the terminals and the vessel conversions themselves. And this is where we are in terms of running that program. There's a lot of governance that has to happen, obviously, for something this big. So we've put together our own business case to demonstrate ourselves and our own board of directors that this is a good idea and that there's some benefit to not just to the environment, but also to BC Ferries business by doing this. We have gone out and we have received approval from our own board of directors and from the BC Ferries commissioner that this is a good investment and that we should go ahead. Worth noting that we actually got really good support for this. When we went out either to our own governance bodies or when we engaged with community stakeholders around the province, we had very good support from this. Just about universally, everyone said, this is a great idea, you should be doing it, go ahead. We support, which is not always the case with projects that we want to run, but I think there's a lot of people who see value in electrifying the vessels and improving the environmental footprint of our organization. We've engaged 2 different companies. So SNC-Lavalin is doing some engineering work for us to look at the terminal design, what kind of transformers we need, what kind of boards, what kind of structures, what kind of connections. And Diamond Shipyards, who's the original designer of the vessels themselves, has done a lot of work to figure out how we should, run the cables, where we should put the battery packs, what kind of additional cooling is in place. And so those design details are now available to us. And we're working quite closely with BC Hydro every step of the way, so we keep each other informed, because obviously they're going to be big stakeholders in this. And they've just actually given us some information that they will be able to support the charge powers that we're talking about to recharge our batteries between crossings. Which brings us to what are we going to do next? Well, really the next step for us is getting the funding in place that we need. So, it's not a cheap undertaking to do the conversions, and particularly for the modifications that we need at our terminal side. So we have gone to the federal government asking for some support to get this done. There are grants available. There are programs that are available through the federal government that will help us offset some of these high costs of converting the vessels. You may have heard that there was a federal election recently, and the result of that is that we were kind of delayed getting our applications in and approved because everyone in government was preoccupied with other things. So now that the election has been settled and government is going to be stable again, we look forward to pressing on with this, to seeing exactly how we can get our applications in and how much support we might be able to expect from the government. Once we know that level of funding support, which is really critical to our project going ahead, we'll be able to finish up the detailed planning for things like timelines and schedules and budgets and so forth. I've mentioned the federal government here on this slide. We have got some good dialogue with the provincial government as well, and through various programs for carbon credits, we're able to get a good level of support from the province as well. So it's now the feds who we're targeting to help us push this across the finish line. So with that said, that's kind of a high level of overview of where we are with the Island Class Electrification Program, and I think Bruce and Miles will be able to speak to some of the more details. So Jamie, I'll pass back to you to moderate the next piece of the presentation. Thanks very much.
Great, thank you very much. Great, thank you. And as Eliza, I think in the chat room, you can put Q&A onto the Q&A piece and we'll answer questions at the end of the presentations. There's 62 of you, I understand, out there. I can't see you, wish I could, but this is the way the presentations have been working recently. So look forward to some questions of our presenters as we move through. Our next presenter is Bruce Patterson. Bruce is the Director of Naval Architecture at BC Ferries. He manages the Fleet Technical Engineering Group that provides technical support to the BC Ferries fleet, including underwater radiated noise. Bruce has a master's degree in ocean engineering from Memorial University of Newfoundland and over 35 years experience in the marine industry, including 18 years with us at BC Ferries. Bruce, over to you.
Just trying to get my video started there. Yeah, so good morning, everyone. I'm going to be speaking, sort of pitching in for my colleague Shanu Bay, who was called away on a trial this morning. So I'm going to be doing a certain amount of ad-libbing, but hopefully I can stay on topic, which is the underwater radiated noise aspect of our work at BC Ferries. Next slide, please. So in terms of environmental issues at BC Ferries, obviously there's a multitude, some of which are regulated, some of which are not. But when we're approaching new designs, there's been an evolution where there's two issues that are really top of mind. So there's the greenhouse gas emissions aspect of things, which speaks directly to the electrification topic that we're speaking about today. And then the other aspect is the impact that we have on the underwater environment. And that's abbreviated as underwater radiated noise, or URN. It's a concern not only with the Island class, but with every vessel that we operate. Next slide, please. So in terms of understanding the URN issue, and as it pertains to shipping, and the slide some of you may have seen because it's in the Port of Vancouver presentations. There's a number of sources of noise. There's obviously the machinery on board. There's the noise that the hull makes as it passes through the water. Supportive machinery like the bow and stern thrusters. The propeller noise, the stuff that we hear by way of vibration or noise. And then there's cavitation, which is a particular aspect of propeller design where the tips of the propeller, and ideally nothing else, but it can happen on other parts of the propeller, is generating noise through the process of putting water into its vapor pressure point, and that's called cavitation, and it generates a high frequency noise. So the majority of the noise sources that you're looking at here are very low frequency noise levels, and they don't tend to radiate out into the environment very far because of the interface with the water surface. So we experience them on board the vessel, but they don't necessarily go very far out into the environment. Whereas cavitation is a primary source of noise into the underwater environment. And that's what our focus has been at BC Ferries. So next slide, please. So this is some research that was done by a European organization, but it sort of tells the tale of how important cavitation is as a noise source in the underwater environment. So if you look to the upper left, while this pertains to a large ferry, the contribution of propeller noise and cavitation is quite low at low speed. But when you hit a certain speed threshold where you have what's called cavitation inception, the propeller noise from cavitation begins to dominate. And then clearly as you get into sort of the cruising speed range, in this case 18 knots, 25 knots, cavitation is absolutely the dominating noise effect. Next slide, please. So the impact on marine mammals and again, this is a slide from Port of Vancouver, so again, some of you may have seen it before, is that marine mammals, and particularly orcas, rely heavily on sound for their existence. So they use sound, very high frequency sound, to echolocate prey. That's the clicking that you hear. They communicate at a slightly lower frequency. That's the whale songs that you often hear recorded. And then, of course, there's just the overall stress of noise in their environment. And it goes back to the earlier slide where sound propagates underwater about 4.5 times more than in air. And so, again, just normal marine operations is a significant source of noise into the environment. And so at BC Ferries, working with various experts, we've developed an understanding that it's not just noise in general, but there are specific bands of noise that can particularly interfere with activities of the orca, and in particular the southern resident killer whale population. So high frequency interferes with their ability to hunt and find food. Lower frequency can interfere with their ability to communicate. So it's not just a general problem. It can be quite specific to the species of interest, in this case, the species at risk, which is the southern resident killer whales. Next slide, please. So we're engaged in a number of activities at BC Ferries to help mitigate our impact on the environment. We are by no means the noisiest source of vessel noise in the environment, but because we operate exclusively in BC waters and in the area where the southern resident killer whales operate, because we're constantly there, we recognize that we are a significant influence and impact on the success of the southern resident killer whales and other marine mammal populations. So we engage in a number of different ways. So the first bullet point speaks to the fact that we have been working with a number of research organizations. I mentioned Port of Vancouver. We've been working with the federal government, the Transport Canada Research and Development Board. And one of the major ways that we support research and development is that we make our vessels and our terminals available as platforms for researchers to test out technology and to also get a better understanding of what can be done to help mitigate noise into the marine environment. And then the second point, since about 2017, we've been engaged in documenting the URN performance of our fleet, not just our new vessels, but all of the vessels that are operating, particularly in the Salish Sea area. And so it began by working with Port of Vancouver and the ECHO program, where they've had a microphone in the water documenting shipping in general. Originally, it was off of the Tawasin Coal Port. So again, we got a lot of data on ferries going to Tawasin and Duke Point. But we also have conducted dedicated programs where we put our own microphone in the water, engage subject matter experts to collect the data, review it, and we've developed some profiles and some performance on our fleet, and we're able then to incorporate that into the next bullet point, which is to try and build quieter vessels. I mean, once we've categorized our noise levels, we then are working with subject matter experts to understand what is possible to make them quieter. The other aspect that we, of course, can do is develop procedures for quiet operation, so that when we know that we're operating in an area where southern resident killer whales are present or some other species at risk potentially, that we're able to manage our noise profile by either slowing down or in some cases just changing the operational profile of the vessel by going to a different setting on the propeller, or avoiding the area would be an example of an extreme case where we're seeking to minimize our impact. And then the final point speaks to the fact that we have a very extensive whale documentation program. So our bridge teams are educated in terms of what to look for and how to document the various species that we encounter in our operations all up and down the coast, and so we have a training program with regard to tracking and documenting whales. So next slide. So one of the specific projects that we've been engaged with Transport Canada on, and also as a partner with Det Norske Veritas, or DNV, which is a classification society, is attempting to understand what we would need to do to design a quieter propeller for our new ships. So we've been using a couple of our existing major ferries, and the hull form in the upper right is of the coastal class ferries that run on our major routes between Vancouver Island and Vancouver, and starting by working with the existing propeller design and then figuring what we might do to come up with a quieter blade. So the plot on the lower right hand side sort of shows the way it might be modified to reduce the amount of cavitation, which is the white area to the right hand side of that plot. And on the left hand side, the graph shows what we might do in terms of trying to comply with some standards that are generated by the classification society. So the orange line represents the target noise values that we're trying to achieve, and then the blue and the red line represent results of modeling to try and get a quieter propeller. And so you can see that we're starting to get a better understanding of what we might incorporate into our newer ship designs to be quieter, reduce our impact on the environment. Next slide. So to summarize, obviously BC Ferries has been engaged, understanding that we are a major contributor to noise in the marine environment, in the Salish Sea. And so we have been engaged almost right from the very beginning with the research community to address this issue. We recognize that a major source of underwater radiated noise is from propeller cavitation. So, there's the stereotype from submarine movies, you switch to electric power and you all of a sudden go quiet. But when you think about it, if you're turning your propeller at 200 or 300 RPM, it's making the same amount of noise regardless of how you're driving that propeller. Okay, so the challenge that we have is the third point, and it goes back to the original slide where we're looking at emissions and underwater radiated noise. There are things that we can do to reduce the amount of cavitation on a propeller, but it actually results in a lower efficiency propeller. And the consequence of that is that you then have to consume more power and more energy to propel yourself at a given speed to maintain a ferry schedule. So the contradiction here is that we can reduce our underwater radiated noise signature at the cost of potentially higher fuel consumption and therefore higher greenhouse gas emissions. So the segue into electrification is that zero emission propulsion, such as electrification, would allow us to accept the penalty in underwater radiated noise in terms of efficiency and minimize the cavitation without the consequence that one would get in greenhouse gas emissions using a more conventional energy source. So that's kind of the tie-in to the Island Class electrification and underwater radiated noise. So with that, I think I'll hand it back to Jamie. Thank you.
Great. Thank you, Bruce. Appreciate that. Looking at the questions and answers, there's 4 there right now. I think more questions. We'll be answering those at the end of the next presentation. Just for the panelists, I think question 1 will probably be Bruce, just so you get a heads up, Bruce, and then Ed will take care of the second, third, and fourth question, and we'll see how it goes from there. Our next presenter is Miles McKinnon. Miles is a professional engineer with BC Ferries. He's currently the engineering manager responsible for electrical and automation systems in new vessel construction, as well as supporting the operational fleet. Prior to joining BC Ferries, Miles was a civilian electrical engineering officer serving the Royal Canadian Navy here in Esquimalt. Miles is an advocate for energy transition in the maritime sector and the low carbon economy. Welcome, Miles.
Hey, good morning, everyone. Thank you very much for joining. I'll jump right into the presentation here. I'm going to speak about more on the electrification project, touching on 3 topics: why electrification, ferry electrification is important, how does it work, and what are some challenges. So I'm going to start off with why electrification is very important for ferries, and just a slide or 2 on some carbon or some climate science here. This is a graph showing really highlighting the skyrocketing carbon concentration in the atmosphere. And if we look back about 1 million years, we can see some natural fluctuations in CO2 concentration. But it's really this last 100 years on the right, the post-industrial period, where our carbon has really skyrocketed in the atmosphere. So that has a number of different effects, but really one of the more concerning one is shown here, which is the global temperature rise. And looking again at that post-industrial period, we can see temperature climbing and correlated to the concentration of carbon dioxide in the atmosphere. And the temperature changes we're talking about here, it's looking about 1 degree. Doesn't sound like a lot, but the Earth is so sensitive to temperature change, and that's why in 2015 in the Paris Agreement, the target was set to limit global temperature rise to less than 2 degrees. So it's really quite sensitive to temperature and our carbon dioxide from fossil fuels. So with that said, jumping into the electrification project, it really represents a big milestone and a big opportunity for BC Ferries, because it's our first vessel that's really built with a operation in zero emissions mode in mind, and powered by a renewable energy source, which is very low carbon BC hydroelectricity. So yeah, to summarize where we're looking at deploying Island Class, it's a smaller ferry serving between Vancouver Island and some Gulf Islands, as well as a route here, Powell River to Texada. What enables this project to be a good candidate for electrification is the fact that it's fairly short runs. I've got the distances for each of the routes there, and they're quite short. So that means that the ferry doesn't consume nearly as much energy as our large vessels making crossings say, between Vancouver Island and Vancouver. So the batteries and the charge power are much on a lower scale. So how does the technology work? For starters, we need, even though it's amongst our fleet, it's a smaller size vessel, we still need a really big battery. And to kind of put that into perspective, the battery that we have on Island Class now, operating as a diesel battery hybrid, would be roughly the size of 15 sort of standard Tesla Model 3s. When we upgrade that for electrification, that would bump it up to about 37 Tesla Model 3 equivalents in energy storage. So it is a big battery, even though it's one of our smaller vessels. Here's a photo from one of the battery rooms on Island Class. We have 2 battery rooms that the capacity is split between. So this is half the ship's battery capacity, 400 kilowatt hours of lithium ion. This is, you can see there from Corvus Energy, which is a company that started off in our neighborhood here in Richmond. So this is the battery that we have on board. And what you can't see in the photo is a lot of empty space in this battery room, because the ship was designed with expansion in mind. So in these existing battery rooms, we've got space reserved to upgrade to the full capacity that will support electrification. The powertrain on the vessel is designed electric already. So here's a shot from the thrust room on the vessel, but just highlighted in red there is the large electric motor, which is producing the power to turn the propeller. So that's already electric. So that means that the vessel is in great shape to adopt full electric operation, as well as maybe in the future some alternate energy source, renewable energy sources. It's that electric powertrain is really key, and it's delivered with that all set up. So that big battery needs to be charged, and it needs to be charged likely for most of these routes. It's going to be charged at every docking. So and our dockings are short. It's a small vessel that doesn't take a long time to load and unload. So typically we're in dock for about 10 minutes. So we need some way to connect up to our BC Hydro supply and get that energy into the batteries. So here's a graphic that it doesn't represent what our final solution is going to look like, but it gives you an idea of we have to have a new charging system that will be installed at our berth, that will be some type of a high power connector that will be mate with a receptacle on the ship and transfer that power into the batteries. That high power charging I mentioned is really high power, seeing as we have to get that energy in the battery in that very short period of time, the 10 minutes. So just to put that into perspective from some other charging that you may be more familiar with, if we look at a typical EV charger that you may even have at your home, a level 2 charger, around 8 kilowatts of capacity. Tesla supercharger bumps that up a lot to 250 kilowatts. We're looking at charging at about 3,500 kilowatts would be the maximum charge power for Island Class. So it's a very high power charge, and that's what drives some big infrastructure upgrades and the work that we're doing with BC Hydro to get that service out to the terminals. So some of the challenges in the project. The number one challenge of a battery electrification project is the energy density. So what's shown here is trying to make an equivalency between one of our battery packs and fossil fuel, and how great fossil fuel is as an energy storage medium. So one of those battery packs that I showed from our picture of the battery room is in electrical terms, it's 100 kilowatt hours of energy. If we look at how much diesel we would burn to get that same amount of energy that the battery pack stores, even with the losses in the engine, that would equate to about 17 liters of diesel. So it would be a little bit less than this jerry can here. So and then if looking at the weight there on the left, it's you'll say about 1.6 tons for that battery pack, 14 kilograms for the diesel. So that really puts into perspective the challenge of powering ships and large industrial machines with battery power. It's the batteries are big and heavy, and there's so much energy in fossil fuels that we take that for granted. Here's a picture of one of our terminals that the Island Class are currently sailing out of. This is the west view out of Powell River, and just highlighting a few of the challenges here is that connector system that I showed the sketch of. That's got to get integrated into our existing berth design, and which was not designed for that type of an electrical connector. So each terminal has some unique challenges. They all have a slightly different layout, and they all need to be standardized because our Island Class vessels need to move amongst the different routes and be able to plug in. So that is a big challenge, coming up with a solution that's going to be work at all the terminals and reliable. In addition to that, we have a big tidal range here in coastal British Columbia. We have 5 meters, or in some extreme cases up to 6 meters of tide. So the vessel, its position is going to change, and the charging system has to be able to accommodate that reliably and repeatedly. And then looking back further away from the berth here, up to the upland of the terminal, this is where we need to have some new electrical equipment to bring in that high power service from BC Hydro, a new electrical building to house some of the equipment to bring that power down to the berth. So every terminal is going to be a little bit of a unique solution to be able to fit all that and integrate it into our existing berth design. So that highlights some of the key challenges that we're working on. And yeah, with that, that wraps up my presentation. Thank you very much. Back to you, Jamie.
Great, thank you very much, Miles, and thanks to Ed and Bruce as well. It looks like we have about 17 minutes for questions before we wrap at 11:55 to keep this on time. We've got 6 in the Q&As, and they look like good questions. So I think we'll just dive right into them. If Miles, Ed, and Bruce, you can turn your cameras on to be part of the panel. I think one of the questions I read in the chat a few minutes ago, will the presentations be available? Yes, we'll make sure that Coast has them and makes them available to anybody who wants them. So that's part of it. Let's go right to the first question. It's an anonymous question. BC is home to one of the world's leading hydrogen fuel cell companies, Ballard Power, of course, and their long-term position in this technology applies really well to larger, more industrial-oriented heavy equipment. How have these alternate batteries been considered, or have they, and why or why not? I don't know if Miles or Bruce, you want to take a stab at this?
Yeah, I could take a stab. And so, fuel cells are another low carbon, a potentially renewable energy source. And we're starting to see them being introduced on some vessels just sort of in the last 1 to 2 years. They're starting to be introduced onto some vessels globally. For Island Class project, where they're fairly short runs and the energy requirement is lower, that's what really makes them a great fit for batteries. And the big advantage to that is the efficiency of batteries. We have very low losses. When you charge energy batteries from BC Hydropower and then use that energy, it's very, very efficient. Whereas if you take BC Hydropower and produce green hydrogen and then use that in a fuel cell, it's extremely inefficient. Actually, there's about you're only going to end up with maybe 25% or less of your energy that's actually usable at the end of that. The rest of it is waste. So that means that you're still going to have a fairly low carbon solution in the end, but your cost of energy is going to be quite high. So it's the right solution for some applications, but if battery will work for you, it's going to be a much cheaper energy.
Great, thanks, Miles. Second question in the Q&A here is it a temporary hybrid while waiting for the wiring and the terminal infrastructure, or is it a plug-in hybrid once the terminal is wired? In other words, do the diesels stay in forever? Ed, do you want to take a stab at that?
Yeah, thanks, Jamie. I'll jump straight to the answer on that one. The diesels will stay in forever. Why is that? It's primarily for reasons of redundancy and having a reliable ferry. So, we know that on Vancouver Island and northern parts of BC, we're prone to power failures in the winter. Winter storms come through, people are without power for a couple of days. Maybe we won't be able to recharge every single day. So we want to keep the diesel engines in primarily for the reasons of reliability and being able to sustain our operations. There are going to be cases as well where we may fall behind schedule. We may have to do a longer route. We may have to run further. We may have to take the ship out of service and send it to our facility. where we would want to have the diesels available as well. So there is going to be some opportunities and some routes where we may have to run in a sort of a plug-in hybrid configuration. But we think that most of the routes, most of the time, if we can execute this program, we'll be able to run fully electric, fully battery electric.
Good, thanks, Ed. And we'll one other question here that jumped over to the chat room is, where is the vessel conversion work expected to take place, and what process will BC Ferries use to select a contractor for the conversion work? That question is from David.
Okay, thanks, David. Short answer is in BC. We want to do the work at a BC shipyard, and it will probably be done through a competitive tender process, but we haven't fully developed the procurement strategy yet. Happy to keep you informed as we progress those plans.
Sure, and maybe just speak to the side too.
Sorry, Jamie?
Maybe just speak to the terminal side too, the terminal infrastructure.
Right, terminal infrastructure again is going to be a competitive tender. We've got a number of different terminals. Miles showed the map on his screen, so we'll be looking at a procurement strategy coming together, and BC-based companies will be expected to bid on and do that work.
Great, thank you. And another question from David D here. With BC Ferries moving all vessels to electrical, are you going to change all your emergency ribs or rescue boats essentially to electrical motors also? If so, why not? If yes, what kind of motors are you going to use for the emergency rescue craft that we have? I think I can answer that. We don't have any exact plans at this point. The big wins for BC Ferries is the large vessels, obviously, the largest consumers of energy and fuel, and ergo, they're the largest polluters, if you will, in terms of emissions, air emissions and things like that. So the real big wins will be in our new majors, and there's a question coming up about that in terms of a replacement as we replace some of the new major vessels on our major routes. Those will be the biggest wins in terms of environmental wins and reducing our carbon footprint. But I think it's something that we are going to look at as time goes, but we don't have that on our immediate horizon right now, David. So thank you. Another question, does BC Ferries have broader plans for decarbonization beyond the Island class? For example, less vehicle dependency, i.e. imagine multimodal integration on both sides of trips, and please put more cycle infrastructure in place. Bruce, do you want to try that one, or?
Yeah, sure. So we certainly do have broader plans. We have milestones within our existing vessels. We call them quarter lives, mid lives, 3/4 lives, where we truly look at the ship overall, and obviously decarbonization, alternative fuels or conversion to full electric will be a consideration for any one of those projects. The comment about cycling, we have engaged with various cycling coalitions over the years in sort of fits and starts, I'll admit. So the comment is noted, and obviously with regard to moving to less vehicle and more foot passenger traffic, that's a trend I think we've seen in our traffic. But obviously we're not in a position to lead that. Our customers are there. But certainly I think it's a trend as that trend evolves in society overall. We will be interested in following that as we develop the specifications, for example, for our new major vessel program that is coming up.
Great, thanks, Bruce. Here's one for you, Miles. It's from the chat room. Are you having to implement any additional or different onboard firefighting systems with the incorporation of battery power?
Yeah, it's a great question, and the safety aspects there are a primary concern. The ship has fire suppression systems in the battery rooms already, because the ship does have that battery there operating as a hybrid. So we do have fire protection, structural fire protection in the compartment, as well as a water mist fire suppression system. So those are some of the features that we've got.
Great, thank you. And that question was from Mark Russell. Thank you, Mark, for that. Another question in the Q&A, Maja. Are you considering energy harvesting systems to extend the range of battery-powered propulsion and or reduce battery size? That one for you, Miles, again?
Could you just repeat that one, please, Jamie?
Sure. Yeah. Are you considering energy harvesting systems to extend range of battery-powered propulsion and or reduce battery size?
Yeah, I think for a ferries operation, there isn't a lot of energy harvesting opportunity. I've seen some stuff, like for example, sailboats where they can kind of use that propeller as a generator in some cases and recover some energy. But for the way a ferry operates, point to point, there isn't really enough energy harvesting opportunities to make a significant contribution to the energy needs of the ferry. So it's there's limited opportunity there.
Okay. Thanks, Miles. We got a few more minutes left here, about 6 or 7 minutes. Here's one from David. How could larger ferries, Spirit and Coastal class, be designed to operate without emissions? Is there a time frame in which replacement vessels could be introduced to address this requirement? Maybe Ed, that one's for you. We talked a little bit about it, but you can maybe go into a little more detail, Ed.
Yeah, that really is the billion-dollar question, though. So BC Ferries has got targets to achieve for emissions reduction, and as I mentioned, you can get them. You can look at them in our Clean Futures Plan, and the only way we're going to get those is by doing something big. We have as a company, we have a certain footprint of emissions, and certainly the majority of those emissions come from our larger vessels, the Spirits and Coastals, and the older vessels. And the only way to get that target met really is by replacing the older vessels with newer, cleaner ones. So the question is, how could larger ferries be designed to operate without emissions? And the answer is, I don't know yet, but we're going to find out. It's the same question that ferry operators all over the world are asking themselves. Everybody wants to build sustainable ferries. Everybody wants to build ferries that don't produce engine emissions and don't contribute to the environment. And we're all asking ourselves the same questions. Is it going to come from scaling up the battery concept that we're talking about on the Island Class? It could do, but there's alternative fuel sources out there, and I think many of us know what they are. There's hydrogen, there's ammonia, there's biogas, there's biodiesel, there's all these various technologies out there that we can think of. And so over the next few years, BC Ferries is going to be investigating those various technologies much more rigorously to find out which are appropriate for our applications and which are likely to be available to us as fuel sources. Who can provide these energy sources to us? So the timeline, which I think was the second part of the question, is over the next 2 to 3 years, we're going to have to do some investigation and decision making. And our plan is to start introducing new large ferries into the BC Ferries fleet before the end of the current decade and start replacing some of those old, higher polluting vessels that are generating the majority of our emissions at the moment. So hopefully that covered some of it anyway. Long answer.
Yeah, thanks, Ed. In this venue, you can't interact with the audience, unfortunately, to see and read the body language if you've answered it correctly. There's another.
I saw that Miles was nodding, so I take that as a good answer.
Yeah, there we go. That's perfect. There's another question in the chat here. Is there consideration to move further, making the electric boat or vessel semi or fully autonomous? Bruce, do you want to try that one?
We kind of maintain a watching brief on the autonomous technology. I'm not aware of any immediate plans to go that way, particularly with the Island Class. But there's no question that is an evolving piece, and it has a consequence for the environment, and that it does result in a standardized operation. You're kind of taking the human factor out of whether a person is heavier on the throttles or not. But at this point, there's no specific plans for the Island Class.
Yeah, maybe just to build on that Bruce kind of spoke to the navigational piece there, which I think was the intent of the question. there is some automation and intelligence in some of the advanced power systems, like what we have on Island Class, where deciding when the engine should be running, at what load, when to charge the battery, discharge the battery. For a human operator to do that all in the most efficient way and get the best fuel economy and reduce emissions as much as possible, it's too much to manage. So we're seeing more automation and intelligence on the engineering systems to get the best possible performance from them. So that's starting to happen now.
Yeah, thanks, Miles. And I'll just add a little bit on that as well. With the new majors that we've talked about a little bit as we're into the design and conceptual and innovative process, we're certainly looking at the autonomous potential. We're remembering that when BC Ferries builds vessels, they operate from 40 to 50 years. We're trying to look on the horizon, which is almost impossible to exactly predict. Understanding what our traffic mix is going to be like, what routes exactly we're going to service, is the frequency going to change? You need different AEQ or auto equivalent unit capacity. In other words, the types of mix of vehicles. So there's a lot of considerations in that as we go forward. But we're certainly looking at it. I was on a vessel 3 years ago that was auto docking and auto crossing, and it was proven technology with Wärtsilä. And that was 3 years ago, the June of 2018 in Norway. And so that technology's out there. There's another vessel, it's called I think it's a Discovery Voyage. I may get that wrong, but it's leaving on September 30th from Hamburg. And it's a consortium of organizations and regulators. And it's going to sail on a 1,000 nautical mile voyage, all fully autonomous, with the remote operations center in, I think it's Boston, Massachusetts, 3,500 miles away, and it'll monitor this system. And it's got all AI sensors, et cetera. And this is all these proof of concept are coming up. So that's something to look for as this vessel navigates its 1,000 nautical mile voyage over the coming weeks. We'll go on to another question here from Tara. Does underwater topography impact the degree of cavitation? For example, is the noise louder in the passes, i.e. I guess active pass, versus the open bodies of water like the Salish Sea? Who wants to take a try at that one?
Well, I'll start with that one, Jamie, and maybe Miles or one of you Navy guys can contribute. So the cavitation is actually at the propeller, so that's the source of the noise, if you like. That's if you think the loudspeaker. Where the topography comes into play is basically, as you've inferred, how it gets transmitted out into the environment. So a particular type of bottom structure will reflect that noise more easily than, say, another type. And so this is what makes testing and comparing vessels really problematic, because you need to almost test them, as we've been doing, in the same area so that you have the same conditions applicable. So its temperature, its salinity, its bottom structure, these all have an influence on what you actually measure as a noise impact. So while the source noise may be the same, the impact on the environment will vary very much with the topography.
Thanks, Bruce. We've got one more in the chat or in the Q&A. There's some in the chat that we're not going to be able to get to in the time frame. We'll answer this last Q&A one. If there's any other questions, we can follow up through Coast and through Alicia, and we're happy to answer. We can do that through email if necessary, because we'd like to get to all the questions if we could of today. This one is: incorporating such high power charging stations for vessels require a fundamental boost of terrestrial electrical transmission systems. It is a time-consuming process. I was wondering if there's already been done, or is it being done in parallel? Would like to answer.
Yeah, I could take that one, Jamie. So yeah, there's certainly some BC Hydro upgrades required, and in the work that we've done with BC Hydro, we have a great working relationship with them, and we can say that from the investigation that they've done into their capacity, they've got capacity in the substations in these communities. So, sort of at the transmission level, the really big towers, we're not doing upgrades at that level, but it's more regional in the communities where they might have to move some customers from one circuit to another to free up some capacity for us, or in some neighborhoods, they might have to, Campbell River is an example of an area where they have some more capacity constraints. They're going to have to run a new circuit from their substation out towards our ferry terminal. So those are the kind of upgrades that we're looking at there. And construction hasn't started yet because we're focusing on the engineering side just at first now, and waiting for that federal funding to come through that Ed talked about before we jump into construction.
That's great. Thanks, Miles. And we're at our time now. We're just a minute over. Thank you very much for everyone who participated today, and thanks for your questions. We'll make sure that we get you answers to the questions that we're unable to answer here in person. Thanks for your interest in this. We're very excited at BC Ferries with this project and this program, and the electrification of our fleet, at least the start of it. And we look forward to welcoming you on board our Island Class in the future. Take care.
Thank you, Jamie. Thank you, Ed, Miles, and Bruce for joining us today. And thank you everyone who submitted their questions through the chat. That was such an engaging conversation. I've shared an email address through which you can submit any follow-up questions for today's panelists. It's info@canadacoast.ca. So please do reach out to us directly if you want to continue the conversation. I'd also like to invite you to join us for our next Coast Talk on October 20th at 11 a.m. Pacific. You can join Lisa Kalinchuk, VP of Research at the University of Victoria, for an in-depth look at tidal energy. You can sign up for this and future Coast Talks on our website at canadacoast.ca and view past talks on YouTube. In the meantime, to learn more about Coast, you can also head to our website and learn more about becoming a member. Membership is free for a limited time, and early members have an opportunity to help us build a clean tech innovation hub here on Southern Vancouver Island. Thanks again for joining us, and we will see you next month.